Hi everyone, I'm Yuanliang Zhang from National University of Defense Technology. I'm here to present our work, an evolutionary study of configuration design and implementation in cloud system. This is a joint work with University of Illinois and Cornell University. Nowadays, in many cloud systems, configuration complexity has increased rapidly over time. For example, in HDFS, the configuration parameter has increased more than 7 times in about 10 years. Previous work mainly focused on misconfiguration detecting and diagnosing, which is post-mortem. The damage is already done to the system. We also find that many developers are struggling to design and implement configurations. For examples, is a parameter useful? Can we reuse an existing parameter? What is a reasonable default value? In our view, compared with software architecture design and software testing, configuration design and implementation have been largely overlooked as first-class software engineering endeavors in cloud systems. So how can we learn from the evolution history? I'll show an example. This is a configuration parameter in Spark, and it's a catch parameter whose default value is 100. If we look into its evolution history, we'll find that this is actually a parameterization which changed a constant value 100 to a configuration parameter. And because of the compatibility, 100 became its default value. If we go deeper, we'll find the reason behind this is because 100 is too small for real-time streaming calculation, which is mostly more complex in one driver and performance sensitive. So from this case, we can know that sometimes a constant value may not fit for all scenarios, and we may want to change it to configurable. For this specific parameter, we will know that for next time, if we want to do real-time streaming, we may want to change it bigger rather than use its default value 100. So evolution history can help us understand the rationale for the changes and learn design lessons and principles. We have 3 main contributions in the paper. First one is a study and the insights that motivate future research on reducing misconfigurations. We come up with a taxonomy of cloud system configuration design and implementation evolution. And finally, we made our dataset and code public available on GitHub. We studied 4 large-scale, widely used, actively maintained open source cloud systems, including HDFS, HBase, Spark, and Cassandra. Overall, we studied 1,178 configuration-involved commits, spanning the recent 2.5 years. For the study part, we combine code diff and issue discussion to do the study. For code diff on GitHub, we use it to do commit identification and source code level categorization. And we refer to issue tracking system, Jira, to find the background and rationale behind every changes. For the detailed methodology of how we do commit identification and commit study is in the paper. For taxonomy, there are 3 main categories of configuration design and implementation. The first one is interface. This is the user-facing part of configuration. Mostly are configuration parameter related. For examples, the parameter name, its default value, its value type, value range, and dependence. The second one is usage. This is how the program actually parse, check, and use the parameter, including misconfiguration error handling. The third one is documentation, including user manuals and code comments. We have 16 detailed evolution activities in the paper, and each one is corresponding to one of the activities in this figure. Due to the time limit, I'll briefly go through some of the findings in the paper. For the interface, we find that over 50% of parameterizations were driven by severe consequences, and performance tuning and reliability are common rationales. However, we find that triggering use cases were often poorly discussed or documented. So proactive techniques to find those deficient constants and automating parameterizations are needed. Also, future work should identify and document scenario and workload, including which parameter can be tuned and the suggest beneficial value for different use cases. Default value is one of the most important part of configuration because most users won't even change it. But we find that only 28.1% of default value changes mentioned systematic testing, and 31.3% of default value changes chose values that as a workaround of reported issues without systematic assessment. For example, it probably makes sense to set it to something lower. I'm thinking something like 3,000 or 5,000 would be safer. Those decisions are arbitrary and may lead to worse cases in the future. So systematic testing approach for existing and new default values are needed. For usage, we find that over 50% of checks added as afterthoughts are basic, non-emptiness and value range checks. This is an example of non-emptiness check. And we believe that by automatically generating and adding those simple checks can prevent many damage to the system. After check, throwing exception is common for handling misconfigurations, but this will leave the difficulties for users, especially those users that may not so familiar with the system. And auto-correction is not common, missing the opportunities to help user handle errors. We also find many developers enhance configuration-related log or exception message by including related parameters and provide guidance. So there is still room for configuration-related log or exception message to improve. We introduce 4 levels of message feedback quality to help future developers improve their message quality. And the highest level is a message that contains parameter names and provide guidance for fixing. Parameter reuse is pretty common, but we find it leads to various inconsistencies. For example, this is a consistent that one parameter once used as case sensitive, but next time is case insensitive. This will confuse users and may lead to misconfigurations. And detecting bugs as deviation from similar program behavior could be a starting point to address this approach. We reported this issue and the developer accepted. Documentation is actually well studied in software engineering. However, configuration-related documentation still need improvement. We find many configuration use case, parameter constraint, and dependencies between parameters are commonly added to documents. So documentation as code approach is still needed. As I mentioned, due to the time limit, there are still some findings and many interesting examples in the papers. So please read our papers for more details. Thanks.
Hello, welcome to the Q&A session for the paper An Evolutionary Study of Configuration Design Implementation in Cloud System. I hope you enjoyed the video. I am here with Yuan Liang and we wait for your question. As you know, use the chat aside for asking the question, possibly use the small interrogation mark so I can notice them. And we have a lot of time now for the discussion, Zhang. And while the audience start writing the question, I prepared the one question already for you to start, to warm up the audience, okay? And my question is this, that you focus a lot in the paper on the need of managing the configuration of cloud system. But when I look to the finding that you derived, I think that most of them are general. You could apply to configuration of other distributed system, not necessarily in cloud. Do you agree? What do you think about this?
Yes, I think many of the findings can be applied to other systems, but I mean, some of the findings, they are pretty specific to cloud system, especially the constraint about parameters, and also there are some checking code. But there are other things that can be applied to other systems, like the feedback message, for example, the log or the documentation. I mean, they are pretty general. So
exactly, yeah.
Yes. But as I just studied the softwares in cloud system, I cannot make sure that all the findings can be applied to other systems. So I mean, the most of them can just can apply in cloud systems.
Okay, and also related to this question, do you think that this you complain in the presentation, also in the paper, no, that this configuration is not cared, and we need to give it more importance in the software development? Do you think that this observation that you think would change if you would have looked into proprietary software? You think that the process they follow is more rigorous? It would be, or would be the same? Because you looked into open source.
Yes. I'm not sure whether it's specific to different softwares, but at least in the software I studied, I believe they are not formal enough. And also, those softwares are already very mature and very big software. So if they didn't treat it very seriously, I believe there are a lot of other softwares. They also do not treat configuration as an important area of software engineering.
Okay. I still don't see question in the chat. No one is asking question. So I don't want to take all the space, but if there are not questions from audience, there is another thing that I was reflecting, because I have done in the past some work about working in a DevOps, no? In which
DevOps. I see.
DevOps, yes.
Okay.
Do you think that we could use feedback from DevOps, from the user processes, and this could help better into the how do you call it, the user part? I don't remember the term now. The usage, yeah. So could we take the feedback applying a DevOps process for the configuration problem?
Yes. I think that will help a lot, if we really introduce the DevOps options into configuration design. I think that will really help.
Yeah. So I used it in the past for the case of using the profile of usage for improving the testing process. But yes, it could be also, I reflected from your presentation that it could also be used for improving the configuration practices as a feedback. Yeah.
Yes, because user is a pretty important part of configuration, because it's actually the users who really configure the system. So user feedback will be really helpful. But the problem is it's really hard to, collect all the user feedback from different users. I think that's a difficult part.
We have one question from Sridhar. he says good talk, and ask if there is a data set of cloud systems.
The data set of cloud system. I have the data set of the configuration cases, the commits of this paper. I put it in the GitHub and I wrote the link. A data set of cloud system, is that mean the configuration commits of those cloud systems?
I think your answer is satisfactory, because he asked if there is a data set. So you say there is data set for the configuration, not of the cloud system, right?
I actually didn't get the meaning of the data.
Probably a repository. Probably, Sridhar, if you want to comment more. Or a good idea could be that actually, instead of going through the chat, since we have a few minutes left, you could discuss directly with Sridhar in the discussion room, because in the discussion room, Sridhar can use the microphone and the camera, so you can talk directly. So this is a good idea for you to continue discussion. And I invite everyone to join Zhang for the more discussion about this in the discussion room. We have 2 minutes left. I don't see other questions, so I don't know, just a quick wrap up of what is your current and the next future work, Liang?
I choose 2 of the 5 to try to do future work. One is misconfiguration autocorrection, which is to correct the wrong configuration value when the system is running. Another one is about the timeout configuration, because timeout is important in cloud systems. So I focus myself on the timeout problems in cloud systems, and this can be my next project.
Okay. So thank you, and we have still 1 minute left or so, but maybe we can take this time for clapping you.
Thank you.
And again, please, when the time expires, you can go to the discussion room and maybe you can retrieve the answer from Sridhar if he also joins, and answer other question. So I leave this stage and I join the other backstage. There is another talk again on configuration and testing. So thank you again. Congratulations.
Thank you.
Thank you. Bye.
Bye.
Bye.